Good morning. Here we discuss about the question and answers of coordination chemistry, question number 51 to 60. Question number 1. Calculate the effective atomic number of Ag in AgCN twice minus. Effective atomic number കാണാനുള്ള equation ആണ് atomic number Z minus oxidation number plus 2 into coordination number. ആറ്റോമിക് നമ്പർ ഓഫ് സിൽവർ 47 ആണ്. ഈ കോംപ്ലക്സിൽ സിൽവറിൻ്റെ ഓക്സിഡേഷൻ സ്റ്റേറ്റ് +1 ആണ്. കോർഡിനേഷൻ നമ്പർ 2 ആണ്. അങ്ങനെയാണെങ്കിൽ ഇഫക്റ്റീവ് ആറ്റോമിക് നമ്പർ = 47 - 1 + 2 × 2 = 50. Second question, what are high spin complexes? Give an example. High spin complexes are coordination compound with the maximum number of unpaired electrons in their d orbitals. Example, MnH2O 6 times 2+. Here, manganese in +2 oxidation state and H2O is a weak field ligand. So, there occur a high spin complex. Mn +2 = D5. For a manganese high spin complex, T2G3 Eg2. Question number 3. Explain the term low spin complex with a suitable example. Low spin complexes are coordination compound with fewer unpaired electrons. Example, COCN6 3-. Here, cobaltin 3+ oxidation state and Cn is a strong field ligand. So, low spin complexes occur. Cobalt 3+ = D6. For a cobalt low spin complexes T2G6 Eg0. Fourth question, tetrahedral complexes are generally high spin. Why? Tetrahedral complexes are generally high spin because the crystal field splitting energy delta T is less than the pairing energy P. This means that it is not energetically favorable for electrons to pair, so they move to higher energy orbitals. In tetrahedral complexes, the metal has a coordination number 4. This results in less crystal field splitting, which means that the pairing energy is greater than the crystal field splitting energy. Electrons move to higher energy orbitals rather than pair, resulting in a large number of unpaired electrons. This makes the complex paramagnetic and high spin. Question number 5. Determine the number of unpaired electrons in FeH2O 6 times 3+, FeCN6 3-. First, FeH2O 6 times 3+. Oxidation state of Fe is +3 and H2O is a weak field ligand. So, the complex is high spin. Fe D6S2 ആണ്. Fe3+ = D5. So, number of unpaired electron is 5. Second, FeCN6 3-. Oxidation state of Fe here +3 and Cn is a strong field ligand. So, the complex is low spin. So, Fe is equal to D6X2, Fe3+ = D5. So, the number of unpaired electron is 1. Question number 6. What are the geometries of the following complex? 1. Nickel CN4 2-. 2. Nickel Cl4 2-. And the complex 3. Nickel CO4. First one is nickel CN4 2-. Here, nickel in +2 oxide state and Cn is a strong field ligand. So, nickel +2 is equal to D8. There are 4 Cn groups. The geometry of the molecule is square planar. And the compound 2, nickel Cl4 2-. Here, nickel in +2 oxidation state. Cl is a weak field ligand. So, nickel +2 is equal to D8. There are 4 Cl groups. Geometry of the molecule is tetrahedral. The third complex, nickel CO4. Here, nickel in 0 oxidation state and CO is a strong field ligand. Here are 4 CO ligands. So, the geometry of the molecule is tetrahedral. Question number 7. Given the number of unpaired electrons in a strong and weak octahedral field of chromium 3+. In a strong field, there occur a low spin, chromium D4S2, chromium 3+ D3. So, the number of unpaired electron is 1. In weak field, there occur a high spin, chromium D4S2, chromium 3+ D3. So, the number of unpaired electron is 3. Question number 8. For the complex nickel Cl4 2-, write the IUPAC name, the hybridization of the metal, and the shape of the complex. The atomic number of nickel equal to 28. IUPAC name tetrachloridonickelate 2 ion. The hybridization of the complex is sp3 and the shape of the complex is tetrahedral. Question number 9. Give an example each for nickel complexes having square planar geometry and tetrahedral geometry. Write their IUPAC name. First of all, example for square planar geometry. Nickel CN4 2 minus. The IUPAC name of the complex is tetracyanidonickelate 2 ion. And the second example for tetrahedral geometry, nickel CO4. IUPAC name nickel tetracarbonyl. And the last question, mention the observed geometries for complexes associated with the coordination number 4 and give an example for each type of complex. For a coordination number of 4, the observed geometries are tetrahedral and square planar. Examples include tetrahedral nickel CO4, nickel tetracarbonyl, and square planar PtCl4 2 minus platinum tetrachloride ion. Thank you.